Once again, these are the formulas that I expect you to memorize, because I think they might ask you about an area of a rectangle, but I don't think they're going to tell you that formula because they're going to expect you to know that. I think they're going to ask you about the area of a circle, but I don't expect them to give you the formula. I think they expect you to know those basic formulas. Now, the first example we're going to look at is not on your packet, and so I want you to just add this problem at the bottom of the page there. It's going to go along with this last rule. The sum of the interior angles of a triangle is 180. So, if you had a triangle, what are the interior angles? Those are the interior angles that add up to 180. Do we remember that? If this angle up here looks like it might be 80 degrees, and this one right here might be 60 degrees, can we figure out what the other one is going to be? How would we do that? So we would add 80 plus 60, and what is that going to be? And all the angles of a triangle together add up to equal what? And so the missing triangle would be 40 degrees. And so that I wouldn't expect something that simple, but you may use that concept about the triangles on some more difficult problem. Did we remember that rule? We remembered this kind of problem? Okay, so when I handed out the worksheet, oh, I'm ahead of myself. There's another one we need to add to that. Your note paper, please, on your ISN, please make this little drawing right here in your ISN. Do we remember vertical angles? If this angle is 80 degrees, how much is that one? Do we remember that? 80 degrees. Do we remember how to figure out that one? That one's not 80 degrees. Do we remember how much that one is? What is the measurement of a straight line? The measurement of a straight line is 180. So this angle right here is 100 degrees. What's this one right here? Now I need you to add something else to your drawing here. If I add another line that's parallel to that one. And do you remember that these double arrow symbols indicate parallel? Do you remember the double arrows mean parallel? I would expect they would probably use the word parallel on the TSIA. And so, can we now figure out these angles down here? If this one is 80, this one is 80 because alternate interior angles are congruent. Have we heard that before? This is an alternate interior angle. This one is 80 degrees because vertical angles are congruent. This is 100 degrees. This is 100 degrees. Now that's if the lines are parallel. There's a little bit of this stuff coming back to your memory now. So, on your packet, would you please look at problem number 1. Now, we did have a formula that we learned in geometry about the interior angles of a polygon. This is a polygon. And you are given this angle, and that angle, and what are you supposed to find? By the way, do you remember that this little M out in front is measurement in degrees of the angle D? I'm not asked to find D and E and F. I'm asked to find the sum of D and E and F. Okay? So, what is the sum of the angles that I already know? What is 100 plus 108 plus 120? Now I'm going to work this problem assuming that you do not remember the formula for the interior angle of a polygon. You don't have to remember that formula if you know that the sum of the angles of a triangle is how much? 180. So I'm going to divide this up into triangles. So the sum of this triangle right here is how much? The angles, of course, I'm talking about. And then, so I don't have any overlapping triangles from the same corner, I'm going to make another triangle. And what's the angle? What do the angles of this triangle add up to equal? And from the same corner, there's another triangle, and there's another triangle, and this angles add up to be what? 180, and the last triangle adds up to be what? 180, so the whole shape adds up to be all those 180s. Well, what are all those 180s when you add them together? Now, again, try to do these things without your calculator. I don't think they're going to give you a calculator to add up all those 180. I don't know which problems you would have for a calculator for and which ones you don't. So do a little practice of trying to do as much as you can without a calculator. All of these angles, A, B, C, D, E, and F, all of them add up to 720. The ones I know add up to 328. So what's my final step here going to be? All of the angles add up to 720. The three I know add up to be 328. To find the sum of the three missing ones, you would make that subtraction. Problem number 2. A cylindrical storage drum is 3 feet tall, a diameter of 2 feet. How many cubic feet are in the total volume of the drum? So we are looking for volume of a cylinder. So we need to start with the volume of a cylinder formula. What's a cylinder look like? A can. And so what does it have on the bottom of the can? A circle. And so a circle is pi r squared. And what's the height? And so that would be the formula. Now, do you have answer choices here? Yes. And so do you see in all the answer choices that they have a pi symbol? That means I'm not going to put 3.14 in for pi. I'm not going to put 22 over 7 in for pi. I'm going to substitute the radius. What's the radius? The diameter is 2. The radius is 1. And so 1 squared, and what's the height? And so what's 1 squared times 3? Only when you write the answer choice, you usually put the 3 in front of the pi, and so you can figure out what answer choice. So that wasn't too terribly difficult, was it? Now, a lot of times they're going to ask you to leave the answer in terms of pi, because if you leave the answer in terms of pi, do you need a calculator to multiply 3 times 1? I hope not. If you need a calculator to multiply 3 times 1, you might not do very well on this TSIA test. So, problem 3, if each side of the square is tripled, the area of the square, and then it gives you some answer choices. So, think about the simplest of all squares. Wouldn't this be the simplest of all squares, a square where the side is 1 centimeter? And what would the area of this square be? How do you find the area of a square? Length times width. Well, what is the length times the width? 1 times 1. So what's the area here? Now, what does it say I'm going to do to the sides? So how much is this side if I triple it? And so what's the area going to be? And so it didn't tell you to draw an example, but by drawing out an example, it helps you understand. Is anything about what I did there very difficult to figure out? But most people choose the answer choice that you just would multiply the area times 3, but that's not true. Which one is the correct answer? No, it's not triple. If you go from here to here, how many times bigger is that? 9. It is not tripled. And that's why you have to draw the picture, because if you don't stop and think about the area, then you think, well, it's just triple. But when you work it out, you can see very clearly that this is 9 times bigger. Because this one got tripled and this one got tripled, and 3 times 3 is 9. Okay, hopefully this would be very easy, because we kind of shrunk it up to save paper. The graph that you have is may not be very easy to read, and so can you tell by counting on the graph, can you tell that that's 10? The base, if you count the little boxes, the base is 10, and it may be a little bit difficult to see. Yeah, but you could tell, I think, where they should be. And the height right here is 4, in case you can't tell it. On the TSIA is going to be a computer test, and so, you can drag it bigger if you need to. And so all of this, all you have to do is fill in the formula, 1/2 base times the height. But you have to know when you're counting on a graph, when you're counting the base, when you're counting the height, you're counting the boxes. And so hopefully you can multiply that out even without a calculator. Can we do 10 times 4 even without a calculator? Can we figure out half of 40 without a calculator? And since it's area, it would be units squared. We don't know if it's centimeters or whatever, so we just say units. Then it tells you what rotational symmetry is. I tried to blow the pictures up a little bit bigger because it may be kind of hard to tell from the picture. When we did this in geometry, we actually took a piece of tracing paper and traced it and turned it. So if I traced this and turned it maybe 90 degrees, would it match back up with itself? Then this one has rotational symmetry. If I traced this and rotated it, would it match back up with itself? It does have symmetry, but it has line symmetry, not rotational symmetry. If I trace this off and rotated it, would it match back up with itself? And so what is the correct answer choice there? Which would be answer choice what? So the triangle is, yes, you would have, sorry, I didn't rotate it around. You would have to rotate it around 180 degrees. Huh? This one's pointing up, and so if you rotated it around 180 degrees, if these two would not actually match if you only did it 90 degrees. You would have to rotate it 180 degrees to match it back up. Good eyesight there. Okay, so again, problem number 6 does not give you a picture. It's often helpful in geometry to make a little diagram. What is the area of the largest possible circle that can be drawn inside a rectangle that has a length of 12 and a width of 10? Would that be it? Would that be the largest possible circle you could draw inside that rectangle? So, what are we supposed to find about the circle? So the formula for area of a circle is area is equal to pi r squared. So I need the radius of this circle. What is this diameter here? If this is 10, this is 10, so what is the radius? 5. So this would be 5 and 5 to add up to equal to the 10. So the area is equal to pi r squared. In your answer choices, does it appear that they put a 3.14 in place of pi, or is pi still in your answer choices? Pi is still there, so what's 5 squared? So the answer is 25 pi units. I don't like units. I like them to specify units, but they don't. But I have never seen a problem where they gave you, like, the wrong units. They never try to trick you quite that much. Okay. A right triangle. Hopefully, you remember that a right triangle is a squared plus b squared equals c squared. Every time you see a right triangle, that's the first thing you should think about, is a squared plus b squared equals c squared. Now, do we remember, excuse me, this formula? And do we remember which one has to be the c? The hypotenuse has to be the c. The hypotenuse is the longest side. The longest side is always across from the 90-degree angle. So in this problem, the hypotenuse is t. And I labeled this one B for base. So applying it to that triangle, this is what the Pythagorean theorem would be using those letters. And so what is it we're supposed to be finding? Area of the triangle. Area of the triangle is 1/2 base times height. This is the base. Where's the height? That's the height. We don't have numbers to fill in. That's what makes this harder. We have to solve this for the h. We have to solve this for the h. That means we need to get the h by itself. So what are we going to do with this b squared? H squared equals t squared minus b squared. we're solving for h because we need the h in the formula. What do you do to get rid of a h squared? So the area is going to be 1/2 the base times the square root of t squared minus b squared. Is that one of your answer choices? I have to back up because it says in terms of h and t. Do we have an h in this answer choice? No. So that is the area in terms of b and t, but I didn't follow the instructions, so I have to back up to this point back over here. See how good it is to have a pencil? So, how do I do that? Well, if I'm going to have it in terms of h and t, what's not going to be there? B is not going to be there. So I solved it for the wrong one. I need to solve it for the b. So I need to subtract the h squared from both sides. The b squared equals t squared minus h squared. Once again, to get rid of a square, you square root. So, in terms of h and t, that means the b is not going to be there. And so this is going to be t squared minus h squared. That's in place. Now, that is the area in terms of h and t, but that doesn't look like any of your answer choices. Because first of all, they multiplied 1 times this. Instead of putting the 1/2 out in front, multiplying by 1/2 is the same as dividing by 2. And instead of putting the h at the back, they put it at the front. So now does it look like one of your answer choices? A cube looks like a 3-dimensional square. So if it is a cube with, it says with length k. So if this is k, how much is this? And how much is this? So the volume would be length times width times height. The volume would be k to the 3rd power. Now then it says you take this cube and increase one side by k plus 2 and another side by k plus 3, and so this would be the bigger box. So the volume would be length times width times height. Now, it doesn't make any difference which order you multiply these together in. So I think it would be easier to multiply the k plus the 3 times the, I keep trying to make an x instead of a k. I like x is better. So this is k plus 2. I just changed the order because you know how to multiply a binomial times a binomial. What do you need to multiply a binomial times a binomial? A box problem. Multiply these together using a box problem. Or, if you prefer, you can multiply them together using FOIL. And so this volume, those two would be k squared plus 5k plus 6 multiplied by another k. So the volume of the bigger box, when you distribute the k, the volume of the bigger box is k to the third power plus 5k squared plus 6k. And it asks you the difference between those two. What does difference mean? Subtract those. So if I subtract those, of course you subtract the smaller one, so I would subtract the k to the third power. If I subtract those, I'm running out of room here. If I subtract those, the k would cancel out, and so this would be the difference after the k cancels out. Maybe I should write that a little bit better. The volume of the bigger box, the volume of the little box, if I subtract those, that will cancel out, and this is the difference. Difference means subtraction. So, it appeared to be a pretty difficult problem, but it's really not anything that you don't know how to do if you just work through it step by step. This rectangular garden is enclosed by 60 feet of fencing on 3 sides and a wall on the 4th side. They like these kind of problems, by the way. One side of the garden is perpendicular to the wall is x feet long. If it's x feet long on this side, how much is it on that side? Because it's a rectangle, right? And this amount of fence is 60 feet. So this top part would have to be the 60 feet minus this side minus this side. Now your answer choice is not written exactly in that form. Which answer choice is this equal to? This is the same as answer choice D. This would be 60 minus 2x. Much easier than it appeared.